Okay, in this video we come back to problem number 82, which we finished halfway in the previous video. So we had the limit as x approaches 0 of cosine x minus 1 over 2x squared. And I tried to separate the cosine x minus 1 over x and then multiply that by 1 over 2x. But I get a 0 for cosine x minus 1 over x. And that's okay, but 1 over 2x when x goes to 0 gives me something that's undefined there. So I can't evaluate that limit, and that just by separating those two pieces there. What I'm going to have to do at this point is to try another method that's often used with cosine x minus 1 or 1 minus cosine x, and that is to use a conjugate of cosine x minus 1. So right now I'm going to erase the bottom part of that. That wasn't something that we needed. And so I try instead to multiply by cosine x plus 1, top and bottom. And the reason I do that is because I'm going to convert this now to cosine square of x minus 1, which can be converted into some multiple of sine square of x. And that is going to help. And so we get the limit as x approaches 0 of cosine square x minus 1 over 2x squared. And if you remember your Pythagorean identity, since sine square of x plus cosine square of x is equal to 1, then we can solve for cosine square of x minus 1, which would be negative sine square of x. Now that brings us back to that first form, the sine x over x, and so I'm just going to Sorry, I made a mistake that I seem to often make in these kinds of problems. I didn't multiply the denominator. I didn't keep the cosine x plus 1 in my denominator. So it should have been cosine square x minus 1 over 2x times the quantity cosine x plus 1. I convert the numerator to negative sine square of x over 2x squared times the quantity cosine x plus 1. Now it's going to work. I'm just going to split this up into a couple of different pieces. First I'm going to bring out the negative 1/2. Then I have sine square x over x squared. So I'm going to write that as sine x over x times sine x over x times 1 over cosine of x plus 1. And remember, the 1 is separate from the cosine of x. It's cosine of x, that quantity, plus 1. Now we're ready to plug in. We plug in x is equal to 0, or we evaluate those limits. Sine x over x are both equal to 1. But when I plug 0 into cosine of x, I get 1 plus 1 is 2. So I'm going to get negative 1/2 times 1/2, which is negative 1/4. And if you were to plug this into your calculator and evaluate this limit the way we have been, then you will see that that is indeed the limit, negative 1/4. So that one is a little bit more complicated than the others. In problem number 83, we have the limit as x approaches 0 of sine of x squared over x. Now this is different than sine square of x. It's not sine x times sine x. It's the sine of x times x. And what we need to get this to work is similar to the problem in 81. We need a denominator that matches what's inside the sine expression. So we would have to multiply top and bottom by x here. And so that leaves us with limit as x approaches 0. So that's limit as x approaches 0 of x times sine square of x over x squared. And that, since it's not sine square of x, it's sine of x squared over x squared, that part becomes 1. And so all that leaves us with is limit as x approaches 0 of x, which is just 0. Now number 84 is going to be similar. We have the limit as x approaches 0 of sine x, and instead of writing cube root of x, I'm going to write x to the 1/3 power. Well, we still need the denominator to match the expression in the sine, so we need the denominator to be x. The only way we're going to get that is by multiplying top and bottom by x to the 2/3. And that then becomes limit as x approaches 0 of x to the 2/3 times sine x over x, and we know that limit is 1. So it just becomes limit as x approaches 0 of x to the 2/3, which is 0. And that brings us through problem 84.